put this one in the calculator, so let's review how that is done. Okay? So you're going to probably write the work, you're going to probably write the answer mostly. Okay? Actually, let's, so everybody grab your calculators. You can do a doc B to get rid of what's there. We've been using them a lot today, so I think almost every class has used the calculator today. All right, so we are putting in these two functions. We've got x cubed. Everybody's going to do this because you've got to be able to do this for the test. Minus 2x plus 1. And then hit enter. Oh, interesting. Okay, and then we've got the negative 2x. And hit enter. Okay, so they wanted us to integrate this between wherever the intersection is and 1. So I need to figure out that intersection point first, because I don't just try to trace or estimate, because I won't get the right answer accurate to 3 decimal places. So how do I get that intersection point? Good, and then drag the thing, right? So it looks like we're integrating from -1 to 1. Okay, so let's write this down. Let's write the setup down. Okay? So we just said that we're going to go from -1 to 1. Which function was on the top? The cubed or the 2?
Cubed.
The cubed. So we're going to do x cubed minus 2x plus 1 minus -2x dx. Now, it says to use a calculator. Do I need to do that by hand? No, we're going to use the calculator to do the whole thing. Okay? And if I remember right, there's a couple of ways we could do that. Okay? Let's see. Menu, analyze graph. Let's try menu, analyze graph, integral. Okay? Menu, analyze graph, integral. And it wants me to, oh wait, I don't think I can do bounded, huh? Never mind. Let's try the bounded. Menu, analyze graph, bounded area. Lower bound, and don't just try to trace over the lower bound. You type it in, right? -1, enter. And then upper bound, type it in, 1, enter. So there's the area. Where did it pop up? I don't have my little number. Oh wait, it's in there, isn't it? What did it come out to be? 2. I can't grab it for some reason. It's 2 though, it's in there. All right, another way we could do this. So you like the other way better? Okay, so the other way is going back to this screen. Practice this with me. So you've got both ways practiced. Okay? You go in the button next to the book.
I just said menu and then calculate.
Oh, menu and that's another way to do it. It's the button next to the book and it gives you the integral symbol, right? And you go from, we said -1 to 1, maybe, to 1. And then you do var. The top function this time happened to be an F1, but make sure you know before you do that. Minus the bottom function var F2. And then throw an X at the end of the D and hit enter. Okay. Then there's another way to do it that I didn't show my group as much last year. This is the way mine mostly did it. So the other way to do it is you go menu, calculus. We're taking numerical integral, right?
Yeah.
And it pops up that way too. Okay? So I was going too fast?
Yes, I was trying to say wait.
I'm sorry. Was Cody being too loud? You got 0? Did you do f of 1 minus f of 2? Let me see what you typed in. It's because you went from 1 to 1. You should get 0. You missed a negative. All right. Everybody okay and comfortable with the calculator? So what are we going to write down for the answer to that one? 2. So this would be a good one on a test where I wouldn't even give you a piece of paper almost. You would just type it in online, 2. Okay? All right. The next one, the picture's missing. You get to sketch the picture. Okay? So, the next one's animated. It's got all the number, I don't know why the numbers are there twice, so it crossed them out. It's got a curve and a line. Okay? So sketch that picture somewhere. All right, we good? We got the picture sketched? Okay, so there's the issue with this one here is that we have technically, if we tried to integrate between the curves, the only area that's between the curves is from here on, right? So it's not always good to integrate going that way. I'd have to do two separate integrals. I can do that, and that's fine. Okay, it's going to pop some stuff up here. So if we do vertical strips, we have to integrate it in two parts. Okay, and it would look like that. Don't write that down. Okay? Shh. We could also integrate in a horizontal strip. So so we could do the same thing, and then we take this equation and subtract that equation. Okay, but it has to be solved for x in order to do that. All right? So let's start by solving for x. So if they gave me the two, because the two functions were, there's the first function, write that one down. Y equals square root of x, because the functions really are kind of there, but not really. And then the second function, to get rid of the square root, we square both sides. So this one here actually is x equals y squared. That's what we would use for that function. All right, the other function is y equals x minus 2. What do I have to do to move the 2 to the other side? Add it. So it's y plus 2 equals x, or x equals y plus 2. So now we're going to use those two functions to integrate. Okay? So which one is most to the right or furthest from the axis? Y plus 2 minus the y squared is what we would do. Let's see, it comes onto the next screen here. All right, and what are we integrating to and from? They didn't really tell us that, but if you look at the picture here, it was marked, wasn't it? So when we're integrating with respect to y, we go up the y-axis. So it was 0 to what? 2. To 2. Okay. All right, everybody, why don't you take a minute and see if you can get that integrated. See if you can finish it from there. No, by hand. You can do it. Okay, do you agree with what they got?
Yes.
Yes? Everybody okay? Okay, we have to, what do we do now? Plug in the 2. Does the 0 matter this time?
Nope.
No, because it's on the bottom, right? So is that what you got when you plugged in the 2?
Yeah.
All right, and you did some more arithmetic and maybe got 10/3? You weren't there yet? Okay, take a minute, see if you've got it. Make sure you match us. All right, we good? Okay, good news, we're going to cross out example 7. So we're going to keep 6 and cross out 7. Okay? All right, so we have to sketch the region and find the area again. Okay. So we kind of need to figure out what this is going to look like. This is going to be some sort of parabola but laying on its side, isn't it? Okay, because it's y squared instead of x squared. So in order to graph that, I may actually solve it for y because it asks us to sketch it. Okay, so I would move the 3 over, and then I divide by a negative, so it's going to swap my signs. And then we're going to do what with the, with the squared to undo it? Square root it. So what ends up happening is you end up shifting opposite direction, and it ends up opening towards the left side. So it's something like this. It should have been plus minus. Okay. This one here is a line. I would just move my 1 over real quick. So y-intercept is -1, up 1, over 1. So that's approximately what the picture looks like. So this would be the region that we are integrating in there. Okay, this time we're going to do a setup, but don't evaluate. All right. So I want you to try that setup first. You're going to use what's typed in black. You need to do the left one, or the one on the right minus the one on the left. So everybody see if you can get it set up. You also need to figure out your limits. Okay, so I'm going to give you a minute and a half. See if you can get that far. You don't need to integrate it, just set it up. Okay, let's check it. What are your limits? -2 to 1, good. All right, what did you use for your rightmost function? 3 minus y squared, because we have to go this way across it, right? We aren't doing the up and down, because the up and down we'd have to split it up. Everybody catch that? So we changed it, we're in this direction. Okay? So 3 minus y squared minus what? Y plus 1. And that's all I wanted you to do, right? Was that. I'm going to go parentheses happy. There you go. All right. If you really wanted the answer, I wrote it down as 9/2 in the past. Okay? All right. Let's look in haiku and see what the assignment is today. What's wrong? Okay, let me go back and do it. Hang on, so I can scribble on it. So, how do you know you're going right to left versus top and bottom? And that's probably the hardest thing about this, right? First of all, your first clue was that it gave you in Y's. Okay? So that's a good clue that you're probably going to go right and left versus up and down. Okay? The second one is if I went up and down on this one, let's see, does it change? Oh, there's a part right here. See right in here how the function is on top of itself. So top minus bottom is different here than it is here. So I'd have to integrate it differently. I'd have to integrate it in two parts. Does that make sense? Okay. So I would be integrating from here to here, and then I'd have to integrate that little chunk by itself. So when I see that I have to integrate in two different pieces, it's sometimes it's easier to go left and right and left then. Okay? Did I answer your question, Elena? Yeah. Okay, good. All right, let's go into haiku and look at what the homework is.